Alright, so here we go. I have a big triangle that has a base of 50 meters. It has two sides that do not make a right angle. We have an unknown vertical distance y, and I do know that this angle in here is 40 degrees, and I know that the angle in there is 30 degrees. Because I don't have a right triangle, I can't use Pythagorean's theorem per se, but I do have two small right triangles. I have this red one on this side, and I have this blue one on this side. So I'm going to just play around with some equations with those red and blue triangles to see what happens. They both have this common vertical side y, which is actually helpful, but I need to do something for the bottoms. If I call this piece x, and the whole thing is 50 meters, the bottom piece over here is going to be 50 minus x. So here's what I'm going to do. According to the blue triangle, I know that the tangent of that 40-degree angle is the opposite side over the adjacent side. I'm going to do the same thing for the red. I know that the tangent of that angle, 30 degrees, is its opposite side over the adjacent side. Right now I want to solve for y, so I want to get the x's out of there. I'm going to do that by solving one of them for x and then substituting it into the other. With the red equation first, I put in the tan of 30 is 0.577. So according to this red equation, I have y equals 0.577x. I'm going to do the same thing for the blue equation. I plug in tan of 40, I get 0.839. So I have 0.839 equals y over 50 minus x. I will distribute that. So I have that. I have 0.839 times 50 gets me 41.95 minus 0.839x equals y. So it's an equal sign in there. Sorry, this is not working very well. Alright, so this minus 0.839. Okay. Now what I'm going to do is I am going to two things. I could set the two y values equal to each other, solve for x, then plug back in and solve for y, or I can just solve for y in one of the equations, plug it in, and call it a day. So I'm actually going to do that. I'm going to take this red equation, I'm going to divide by 0.577. So in this case I have x equals 1 divided by 0.577 is 1.73. So x equals 1.73y. I'm going to take that x value and I'm going to bring it all the way over here and plug it in for that x value. So back to the blue equation, I still have the 41.95 minus, I have that 0.839. Now instead of x, I have whatever x is equal to over here, which is 1.73y equals y. So what I can do from here is try to get the y's by themselves and then solve for them. So I still have the 41.95 minus that, the 1.73 times 0.839 gives me 1.45 equals y. I'm going to add the 1.45 to the 1y on the other side, and I get 2.45, so I have 41.95 equals 2.45y. Then I just divide by the 2.45, and I get that y is equal to 17.1 meters tall. If I look at the dimensions of the original problem, that seems to make sense, so I'm going to go with it and say that we're good.